Okay, so 8.3 is area of composite figures. Okay, composite figures are two or more shapes when they put them together. Okay, two or more shapes. So here's an example. Like, I drew a picture of my house for you guys. It's my house, right? Do you believe me? It's my house.
Yeah,
Okay, good. No, who said no? It's totally my house. Okay. So, this is two shapes, right? It's a rectangle and a triangle. Okay? Some common formulas that we're going to use in this section of the book are obviously circle, which we've been working on. That's the pi r squared. Okay? We are going to also use the triangle formula, which is 1/2 base times height. Because obviously we have a triangle right there, right? We're going to use the parallelogram. Parallelogram. Do you remember what that looks like? It goes like this, right? Like a rectangle kind of on its side there, smushed down. That's a parallelogram, base times height. It's the same formula as a rectangle though, isn't it? And then the trapezoid, which this formula nobody remembers ever. But it's 1/2 times the height times the bases added together. So you could have your bases. The height would just be one piece of the, like one of the little triangles on the end, basically. That would be your height. So parallelograms, trapezoids. Okay? Let me zoom it in. Zoom it. I'll make it bigger. There we go. The bases, B1, B2. Does it matter which one's B1 and which one's B2? No, we're just adding them together, so it doesn't matter. Okay, here's an example. Example 1. We're going to find the area of this composite figure. So I have like half a circle and I have a triangle. The area for the triangle, it only works when you have this right angle there, so that's why they put the right, okay? The formula only works when you have that. So what you do is you kind of like solve them separately and then you add them together, right? So let's do the semicircle first, since we just finished circles. So that's pi r squared. What's the r here? Anyone know? Do you think it's 6 or do you think it's 3? The radius. Who says 6? Who says 3? It's 3, because that's like the height as well, so we have to cut it in half, right?
Wait, what? Where's the 3 coming from?
Half of 6 is 3.
Oh.
Okay? But remember, it's a semicircle, so we're doing like half of that formula, right? So you do 3 squared is 9, right? 9 times pi, and then divide by 2. And you get 14.1 meters squared. So that's this piece right here. Any questions on that? We just did like a lot of that. McKenna?
What is the bottom say of the, is that
11
11 meters?
meters. Uh-huh. Okay, then we want to get the area of the triangle. So we do 1/2 times 11, because that's the base, right? Times 6, that's the height. 11 times 6 is 66. Half of 66 is 33. Yeah?
I don't understand the area of the semicircle. Why do you do half of
Half. It's a half circle. It's not the whole.
Why would you do half of pi? Why would you do half?
You're doing half of the whole thing, but you can take half a pi. It doesn't matter.
So you're just doing pi times
Yep. Okay, you just divide by 2. Alright, so we have 33, right? Everyone agrees? 11 times 6 is 66. Divide by 2 is 33. So then the final step is to add the two together. So we add 14.1 plus 33 and we get 47.1 meters squared. Yeah.
Why are you dividing by 2 if it's 1/2?
Multiplying by a half and dividing by 2 is the same exact thing.
Oh.
So if you put in your calculator times 0.5, it's the same as hitting divide by 2. Okay? Good question. Okay. Other questions on this? Yeah.
How can you divide 11 times 6 by 2?
That is the formula for the area of a triangle. Yes. Which part? We'll keep going. Maybe you'll catch on the next example, okay? Okay, we got this written down? All right, next page. Okay, the other kind of question that comes up is this kind where they'll give you, they want you to find the area of the shaded region. Okay, this is a lot more common than the other one.
Can you give us a little bit of time to
Yeah,
do that?
draw that beautiful picture. By the way, these pieces right here on the little triangle are 1 inch each, okay? So I just put arrows to show you that. They're each 1 inch. Have you guys done these before with the shaded and you have to find the difference kind of thing?
Yeah, I think
Not
so.
quite. We didn't do that one. We didn't do a shaded one. We just added them together. This is different.
Yeah, we did.
Did you do one in the book right now?
Inch.
Oh, you were talking about the circle one. Yeah,
Yeah, but
Yeah.
not, it wasn't.
yeah.
This one has.
That one, that's right. The circle one. Okay, so this question is most common when you guys see a test, when you see Smarter Balanced, or when you get tests in high school, like state testing and graduation testing. They always have this one on here, and they always have it as a swimming pool with like concrete decking around it. And then they'll ask you what's the area of the decking. They always have this problem. Like I've seen it come up on every single test. So it's the same idea. It's like you're finding the area of one, finding the area of the other, and then subtract. Okay? So this one, we have a height of 5 inches. We have a width of 12, and then these little triangles are 1 inch each. Okay? So what we want to do is find the rectangle first. That's length times width. So 12 times 5 is 60. Everyone agree with that? 12 times 5.
Do you always write your L's like that?
Well, in the formula, they always put this fancy little L, so I want to write it like that so you know what they're doing.
Oh, that's cool.
Yeah. Okay. Good on the rectangle. Everyone's like, yep, I got that. 60.
Yeah.
Okay.
I'm good at drawing rectangles.
Now, we need to find the area of the triangles. There's 4 of them, right? There's 4 of them. So our formula is 1/2 base times height, but there's 4 of them, so we can multiply the 4 on the outside.
Is it always going to be half?
That's the formula, right? Because a triangle is half of a square or a rectangle, so it's half. Okay. So now my base and height are both 1, so that's pretty easy. So what's half of 1?
1.
Half of 1 is
Half. 0.5.
0.5. What's 0.5 times 4? 0.5 is a half, right?
4.5.
So half of 4 is 2.
Oh man.
So if our rectangle is 60 and our triangles add up to 2 total, the area is 2, how do I get just the shaded piece? What should I do with these numbers? Good. Subtract. So if you don't like the half thing, just change it to 0.5, okay? But for me, it's easy to divide by 2. Don't you think it's easy to divide by 2? Yeah. Okay, so after you write that down, we're going to go to page 635.
So does this mean we're done with notes?
Yep, I told you, easy notes. 635, and we're going to do some practice.